A beam of spin-half particles is prepared in the state. This is the state which a spin-half particles like electron or proton is prepared in the state. We can see here that the bases here, the base used is an X component. So in A, this should be in our mind. So in A, what are the possible results of a measurement of the spin component Z? So a possible result of measurement of the spin component Z that we measure, we get a measurement of the spin component Z. So Z have two states, that is the up state and the down. The measurement, possible measurements in spin half particles is either h bar over 2 or minus h bar over 2. This is the only possible measurements that we get. So the up is h bar over 2 and the down one is h bar over minus h bar over 2. So and with what probabilities would they occur? So the probability is the square of the inner product. So what is the inner product? So this is A. So the inner product is like we have this one. Here we will write what we want. What's out? What we want is what this one and this one. We will do it step by step. And then what's in? And then squaring it, this is the inner product. Okay? Squaring it will give us the probability. So the inner product, also named as probability amplitude. So squaring it will give us the probability that we want here. So the out one, we will mark it as red, which is these two, and the in, which is the state that is prepared, the particle prepared in. So how it came, like the particle came to the analyzer. So we want to measure how many will get out here. We want to measure how many will be in the positive state, up state, and how many will be in the negative state. So to do that, we will use this thing here. Okay? So now how we will do the inner product. So we have the out, this one will be, and we have the in. This is the in, this is the out, as you can see here. So we will do the first inner product for this, then we'll do this one. Okay, first one. So we have, as we can see, the component here is X. Yeah, here the component is x. We will write it as it is. Okay, we can see here the component is x. How we would multiply here we don't have a label, so it is z component. So how we will multiply the z component with x? We should convert this x to z. We know how? Yeah. Okay. First, before we convert it, we will write the whole state here. Okay. So to multiply, this is like, here we have like multiplication. So to multiply, we should have same components. Here x, here z. So what we will do, here is the x, we know it in term of z. And we know this one in term of z. So we will change them in term of z. And then we will multiply by the z component, positive z component. Okay, then we will do the same for the negative. But right now we will make this one. So we know that the positive state of the x is equal to the negative state, the positive state multiplied by half. Okay, positive state, this one. Okay, plus the negative state. How we will get this? How we got this? Actually, maybe I will do another video to explain it. The negative x, okay, will be positive minus the negative state. So we will write these here. We will write them here. Yeah. So to write it, I need a space. Yeah. So we have this one. So we will put this one is equal to this one. We will put it here. Why? Because we want to multiply by z component, and it's x, so we will write it in terms of z. Okay, so we will write this one. Okay, 1 over root 2 multiply by this, so plus. Okay, still we are not multiplying the state here. Still we are only substituting. Okay, plus this one. Sorry for my handwriting. Okay, plus. So finish, we substituted this one by this one. Okay, now we will substitute this one by this one and this one. Yeah. So it is I 3 over root 13 multiplied by this one, which is this one. Yeah, or this one. 2. Okay, that is positive state minus negative state. So now we have this equation. This, yeah, we can say equation, or what is it? State. So we have the state in this shape. Okay, so now we can multiply this one, this state, by it. We can get the inner product easily because what? Because all the states are in Z. So Z, Z, Z. When nothing is written here, it is Z component. Okay? So this one multiplied by this one. So we know that positive state multiplied by positive state will give us 1. Positive state multiplied by negative state will give us 0. So by knowing that, we will get here if we multiply here. Okay, I rewrite it, maybe it's better. Okay, I'll get this one. I'll copy and paste. Okay, so here we will multiply it. Okay, here we need more space to add the state, so we will multiply this inside. Okay, so here will give us 1, here will give us 0, here will give us 1, here will give us 0. So this term will end up being 1. This term will end up being 1. So what we will have, 2 over root 13 multiplied by 1 over root 2 plus, this is 1 multiplied by 1, okay, plus here, this one plus, okay, plus I3 over root 13 multiplied by root 2 multiplied by 1, doesn't count. Okay, so here adding it, 2 plus 3i over 13 plus multiplied by 2 root 26. So here we got the inner product, which is what? The probability amplitude. So if we want the probability, which we should square the inner product, that is, okay, squared. How we will do that? It's not a normal squaring. It's a normal, but it have some idea in it. So we have, this is the inner product we got. So we want to square it. 2 plus 3i root 26. The squaring will be multiply the conjugate. So first I make you remember the conjugate. 2 plus 3i, its conjugate is 2 minus 3i. This is equal to 2 plus 3i square. Okay, that we should know for now. So when we do squaring, we multiply by minus 3i over root 26. That will give us 26 over 4 plus Yeah, because 3 multiplied by 3, 9, and I multiplied by I is minus, and we have here minus, minus goes with minus. So this is what we get, 13 over 26. Okay. Okay, this is for the positive. 13 over 26 divided by 2 divided by 2. This is a tip, okay? You will get half. Okay. If we have any state that is half, okay, this state, okay, I don't know if my explanation will be correct. Yani it's correct, but I don't know if you will understand it. Okay, this state is normalized. The state is normalized. What normalized mean? It means that its component probability of state 1 plus probability of state 2 will give us number 1. Okay, it's like this. Okay, will give us a 1. So if we got here a half, okay, that means the other state, we will count it, but to know that the other state, which is, we have two states, we said, two states, positive and negative. The two state probability, this probability will get it half, and the other probability we should get it half, because if we add them we will get 1. Okay, how to check if this is normalized? Okay, we are going out of our subject. Here we got the probability of 1. We should now get the probability of the second one. We can do the same steps as we did here, but logically we can find it by 1 minus the probability of the first one, which will be half. Now the expected value of the second one will be half, because what we know that it is normalized. It is normalized. We should check it actually, but we know it that it should be normalized, because any measurement will give us a normalized, because it's a measurement, and any experiment should have normalized values. So yeah, it should be normalized. So, and now we will check it by making the same thing for the minus. Here we did the positive. Okay, now the minus component. So this is, we are still in the z component. Okay, in the z component we said the in, the out will be these states. Okay, and their probability will add up to 1, because it's experiment. Every experiment will give us a result of probability of 1. Why? If we throw a coin, half that side and half that side, anything in the nature will give us this. It's like this. Okay, now we will do the second. With what probabilities they would occur, that is the second one. Okay, we have it like the minus. Okay, and this is same as what we did here. Okay, so this is a z component. We can't multiply by this one as it is x component, so we will substitute these two in it, and what we will have we will have this one, okay, that we will use. Okay, I will take it because it's the same, it's just substituting. So it will be the same for the two. Yeah. Okay, this one, if we multiply it by the minus, okay, as we know, minus multiplied by minus will give us 1. Minus multiplied by plus will give us 0. So here by minus, here by plus, no, not by plus, by minus also. Here by minus, here by minus. This will be 0, this will be 1, this will be what? 1, this will be 0. So the difference here, that we will get a minus sign here. The minus will not go there up, but the minus went, okay, with the 0, but here no, okay. So as we will have, this is the inner product, will give us 2 over root 13 multiplied by 1 over root 2 multiplied by 1 plus, which is minus this minus, okay, multiplied by 1 minus 1, this term will be multiplied by minus 1. So I3 over root 13 1 over root 2, okay, that is, okay, 2 over root 26 minus I3 over root 26, that is 2 minus 3i, I3 is the same, root 26, okay. And then the inner product, we want the probability. The probability is the square of the inner product. This is the probability, okay, which was minus 3i over root 26, as we said, multiplying by the conjugate when we want to square a complex number, 3i over root 26, we will get half. You can check it. So as we expected, half. Okay, for part B, okay, we will erase this one. Okay. So for part B, it says, what are the possible results of measurement of spin component Sx? Okay, Sx have any, we said any spin half will have two measurements, that is h bar over 2 or minus h bar over 2. That is positive or negative, but here in component x, the same as the components written here, so no need for conversion. So we'll do for the first one, so it's h bar over 2, h bar over 2 minus h bar. We can use this one, Gemini, to make sure. So Sx components. So Sx components. What about Sx components? Like this is okay. Yeah, it's h bar over 2, or yeah, only ever get 2 possible results. Okay, this in terms of z. Yeah, that's it. Yeah, so yeah. Okay, now to get first one, the probability of the first state, we will do this one, x, okay, multiply by this one, okay, 2 over root 13, okay, that is, no, not like this, sorry, okay, multiply by plus x plus I 3 over root 13. We are multiplying by this one. Here we have it's not necessary to, no, it's not necessary. We don't convert this one to z component because we want the x component. Yeah, so multiplying x by x is a good idea. Yeah, okay, that is minus x. Okay, this will give us 1. This will give us 0. Okay, so 2 over root 13. Okay, this is the inner product. The probability will be, okay, will be 4 over 13. Okay, and then for the minus one, okay, and the x component, so no need for conversion, 2 over root 13, okay, plus, okay, here multiply by the minus, this one, okay, plus I 3 over root 13, okay, minus x, multiply by minus x. This will give us 1, this will give us 0. Okay, why this will give us 1? Because it's orthogonal. Yeah, no, this one will give us 0 because it's orthogonal. This is the same, so it will give us 1. Okay, this is 0, this is, we'll get I 3 root 13. Okay, this is the inner product. To get the see, the inner product give us a projection. Okay, we have I 3 over 13. It's a projection. Projection means any side will be. Okay, when squaring it, we will get a probability. Before squaring, the inner product will give us a projection. Okay, so then the probability will be, okay, squaring it will give us 9 over 30. That is it. Okay,